Good morning, everyone. Welcome to another Monday of math class here with Mr. H on YouTube. So today we're going to continue talking about probability, but we are going to talk about a type of probability which is known as compound events. Okay, so a little bit of context of what that means. We have talked about the probability of one event. One event would be like the flipping of a coin, where we look at how many outcomes that there are. There's two faces on a coin, so that means that there are two possible outcomes, right? Well, what would be then the probability of me getting heads on a quarter 3 times in a row? Okay? Now you may say, well, Mr. Epi, it's 1 out of 2. And, it's like, yeah, you're right, because there's two possible outcomes. But another way of looking at that is that it's 3 separate events. So really, the probability would be 1 out of 2, 1 out of 2, 1 out of 2. And if we multiplied those 3 fractions out, it would be an actual 1 out of 8 chance of me getting a heads 3 times in a row. So that's what we're going to talk about today, and finding the ability to look at possible outcomes of compound events when there are multiple events happening in a scenario. Okay, so I'm on page 734 of our math textbook, so hopefully you are too. Let's look up and see what it says. Find a sample space. The set of all possible outcomes in a probability experiment is called the sample space. Organized lists, tables, and tree diagrams can be used to represent the sample space. So here is what we're talking about with sample space. If I wanted to make, for instance, a table, right? I have for my quarter scenario. Okay, so I make my chart. I've got heads and tails, right? And I've got 3 possible outcomes, right? Another way of thinking about this is that I make a tree diagram where I have heads and tails, heads and tails, and then heads and tails, heads and tails, heads and tails, heads and tails. So this is what's called a tree diagram. Notice how it kind of looks like a branch. And this is used for us to look at. Now, where is the 3 outcomes of flipping a heads? Well, if you look at it, it's right here. It's heads, heads, heads. Okay, so that is how we would work with a tree diagram, figuring it out, right? Okay, so let's look at an example in our book and work through it. There's 3 students chosen to represent Mr. Baldrick's class at a school assembly. All 3 of them need to sit in a row on the stage. Use a list to find the sample space for the different ways they can sit in a row. So we would use A for Adrian, C for Carlos, and G for Greg. Okay? So how do we break this down? Well, we basically can just go one at a time. Since it's alphabetical, let's start with A. So I'm going to write an A right here. And I'm going to pretend this is my list, okay? So A would go first. After that, I go C, since it's Carlos, and then G. Okay, so that's one possible outcome of the students sitting there. But there's others, aren't there? I could also go A, G, C. Okay? Now, this is a good way for us to figure out when do I start a new list, right? Are there any other possible seating arrangements that I could have with Adrian sitting first? No, there isn't. There's these only 2, right? So now let's go to Carlos sitting first. And I go C-A-G, right? C-A-G. After that, I go C-G-A. So far, I have 4 possible outcomes or seating arrangements. Now I'm going to go to my final one since there's no other possible arrangements with C. So I go G, A, C, and G, C, A. And after that, I see I have 6 possible outcomes or 6 possible seating arrangements. So that's how we would do it as a list. Okay, you just list all the possibilities. This is really helpful. Like, you guys maybe have done this with like plexers. I find lists really helpful when you have like names. Okay, it helps me at least. Okay, let's look at a way that we would use a tree diagram. Look down at number 2 with me. A car can be purchased in blue, silver, red, or purple. It also comes as a convertible or hardtop. Use a table or a tree diagram to find the sample space for the different styles in which the car can be purchased. Now, here is the only difference between a list and a table. Okay? The only difference between a list and a table is that I put them in boxes. That's literally it. Okay? That's literally the only list between a list and a table. So that's why I would suggest you guys using lists and the tree diagram. So let's go through this using a tree diagram. So what I always want to do is I want to start with what I need to go with. What is the main, or kind of like the first category? Okay, the first category that they give me in this problem are the colors, and that's blue, silver, red, and purple. Blue, silver, red, and purple. Okay, so that's my color. Now, for each color, there is a possibility of 2 outcomes, right? 2 outcomes. And they can be a convertible or a hardtop. Silver can have a convertible or hardtop. Red can have a convertible or hardtop. Purple can have a convertible or hardtop. When I look at these, I have to count them out. Okay, blue convertible, that's 1. Blue hardtop, 2. 3, 4, 5, 6, 7, 8. There's 8 possible outcomes of my cars. Okay? So those are 2 different methods for solving compound probability. Okay? What are my possible outcomes? What I want you guys to do, I want you to look down at page 734 and look at letter A. Okay? Go ahead and pause the video and see if you can make the possible outcomes. List them. Okay? Use it as a list. If you want to do the tree diagram, that's fine. The example I'm going to show you is how to do it as a list. Okay? So pause the video and try and do A by yourself. Hopefully you've done A by yourself, and the table shows the sandwich choices for a picnic. Find the space using a list, table, or tree diagram for a sandwich consisting 1 type of meat and 1 type of bread. So we're only using 1 type of meat and 1 type of bread. Let's make our possibilities, right? So I've got ham and turkey as my meat, and rye, sourdough, and white bread as my types of breads. So I start with my hams. Okay, I can do ham and rye, I can do ham and sourdough, and I can do ham and white bread. So that's one list. Let's go to turkey. I can do turkey and rye, turkey and sourdough, turkey and white bread. And when I count them up, how many possible outcomes do I have? I have 6. Very good. All right. Hopefully that's making sense to you guys. Let's go ahead and look over then on number 3. Let's get into even a more fun possible outcome. Okay. So a compound event consists of 2 or more simple events. The probability of a compound event just with simple events is the fraction of an outcome in the sample space for which the compound event occurs. So compound events are fractions. Those are the probabilities, okay? And look at that. We're going to go to our quarter scenario, right? So suppose you toss a quarter, a dime, and a nickel. find the sample space. What is the possibility of getting 3 tails? Okay? There's plenty of ways that you can do this. With compound probability, I like to think that the tree diagram works the best, okay? So, does it matter what type of coin you flip in the air? It doesn't. Because the probability remains the same, right? It's 1 out of 2, right? So, regardless, we've got quarter, we've got dime, and we've got nickel, right? And the possibilities are heads or tails, right? After that, I've got a probability of heads or tails, right? I'm expanding. Notice how it gets bigger and bigger as it goes along. And over here for the nickel, I got a possibility of heads or tails, got a possibility of heads or tails, got a possibility of heads or tails, got a possibility of heads or tails. Okay, so this is my possibility. And where are my tails? 1, 2, 3. 1 out of 2, 1 out of 2, 1 out of 2. 1 out of 2 times 1 out of 2 times 1 out of 2. Multiply those across, and I get a 1 out of 8 probability. 1 out of 8 probability. Okay? We have to always look at the possible outcomes that there are when it comes to probability. Okay. Here is your assignment for this morning. On Google Classroom, I would like you guys to comment, what is your answer to letter B? The animal shelter has both male and female Labrador retrievers in yellow, brown, or black. There is an equal number of each kind. What is the probability of choosing a female yellow Labrador retriever? Show your work in the space below. So what I want you guys to do, see what you can see. How many options are there for female and male Labrador retrievers? What is the probability of getting a female yellow lab? Okay, comment in Google Classroom below. Hope you guys are having a great Monday. It's a beautiful day outside. Go ahead and go get some fresh air. Have a great day, guys. Bye.